Okay, so class will start, right? So last class we had started with the second chapter, that is structure of atom. Okay. So why am I smiling something? Okay. So I want to tell you all that on Saturday, okay, like I'll be giving you all a test. Basically just 10 marks test. Yeah, first whole chapter. What I'll do, like I will probably tell you all, it from where like I'll ask. So first, like that empirical and molecular formula, right? One question from that, sure, sure, 2 marks. And second one will be any those laws, no, 5 laws, multiple proportion and all those 5 laws from that one question for 1 mark. Then significant figures, pardon, for the test. Just the law will be like, like you'll have to learn probably like the definition I'll ask you. Okay, so from those 5 laws, no, any one law for 1 mark. And significant figures, 1 mark. Okay, so these 3 questions are sure. Besides that, you will get some more, say 2 or 3 questions from first those 3 questions which I had given, right? Like the 3 formulas I mean. One is number of moles. Then the second one was the volume of gas at STP. And the third one was number of molecules is equal to n into Avogadro's number. That those 3 formulas. Besides those 3 formulas, the last 4, okay, molarity, mole fraction, and mass percent. Okay, so why I have included those questions here, like even for your exams, like your FE1, right? For that also, like mostly like questions will be asked only from those formulas. And probably you all can just go to the starting part I had done, right? Classification of matter and small like theories. So those you can just like go through and read, okay? But don't give that much importance for that, okay? Any doubts? So probably test will be on Saturday. First 1 hour I'll take a class and then last half an hour like I will keep for the test. Okay? Okay. So in our last class, basically we had like an introduction to the chapter. Okay, and we also discussed about electrons, protons, and neutrons. Okay, so now we will, in our class right now, we will basically focus on some theories, some models, and all. We will go through that. So from each model, what you'll have to know is what basically like the model tells us. Okay, like what experiment was performed. Firstly, you'll have to know that, and secondly will be the drawbacks. Okay, like why that model wasn't, the appropriate, okay, like for further on. So these 2 parts, like you'll have to know. Okay. So speaking about electrons, what are electrons? What idea do you all have when I take the term? Uh, yeah, electrons are something negatively charged particles, right? What else do you all know? Basically, where are the electrons found? They revolve around the nucleus, right? In orbits. Okay, not orbitals. Okay, orbits. You said orbit only, right? Okay, in orbits. Okay, you all will further on. You all will know like the difference between orbitals and orbits. Okay. Then what else? What is the mass of the electron? 0. Okay. So mass of electron is basically 0. Now speaking about protons. What are protons? Opposite compared to electrons, right? Protons are positively charged particles. And where are protons found? They are present inside the nucleus. Okay. What will be the mass? Mass is always 1. Mass of proton is 1. Okay, equivalent to 1. Then we have spoken about electrons, protons. Now coming on to neutrons. So what are neutrons? Neutral, just by the name itself, right? It is neutral, no charge. Okay. But will neutrons have any mass? Yes, mass will be 1. And where are they found? Inside the nucleus along with the protons. Okay. So basically we have an idea here. Suppose if this is the nucleus, the nucleus will contain neutrons plus protons. Okay. Electrons will be present outside in orbits. Okay. Basically you have K shell, L shell. So this all things you all will learn a bit further on in the same chapter. Okay. So you all will know that the first shell, like there's basically a formula like 2n raised to 2n raised to 2. Okay. So basically n is basically like the first, like the principal quantum number, like 1. Suppose if n is 1, the first shell will accommodate only 2 electrons, right? Same way, like the second one, the principal quantum number will be 2. So in that way, 2 twos are 4, 4 twos are 8. So the second shell will accommodate 8 electrons, so on. Then the third shell will accommodate 18, so on. Okay. So basically, this is a rough structure of an atom. Okay. So here, starting like what you all have to know is you all have to know like basically where rough idea where it is present. Like this subatomic particles, right? Electrons, protons, neutrons. You'll have to know where it is present. Secondly, charge it contains and mass. Okay. So basically here you'll will find a table, right? So here you'll just have to don't by heart those numbers like like 9.109 into 10 raised to minus 31, the mass and all. Okay. What is important is the approximate mass, right? The last row and the third row. Okay. Like first the charge will be -1 for electrons, protons, it will be +1, then neutrons, it will be no charge. So basically you all just have to remember like, the charge is like -1 +1, 0. Masses, you'll have to remember the last row itself. Okay. Approximate mass. That's it. Okay. And this values, right? If you all solve any questions and all, most probably like, they provide you all. Okay. Like the examiner will give you all like so and so. So no need like to by heart. Okay. So we are done with the subatomic particles. Now we will move on to cathode ray discharge tube. Okay. So, for the discovery now, basically this was the first experiment which was performed, okay, in order to discover the structure of atom. So what was done is this is a cathode ray discharge tube. Okay, so basically this will comprise of a cathode here, which is a negatively charged, and the anode, which is positively charged. Okay. So what was done is the cathode rays were passed through, okay, the system. So it was observed that when the cathode, when we connected, this is basically a battery. Okay. When this particular setup was performed, okay, and the battery was connected, so battery will give you some voltage, right? So when the system was functioning, it was observed that the cathode rays, they were moving, okay, towards the anode. Okay. So first it was observed that the cathode rays move towards the anode. But starting, okay, like since we were not able, or that particular person who performed this experiment, right, was not able to see whether the rays really move or no. But he just moved that, he just knew that when he connected this system, he assumed that the cathode rays must be moving towards the anode. Okay, because why? This is negatively charged, this is positively charged. So he had some idea, that the negatively charged will move towards the positively charged. Okay, but he wasn't sure that, like really it moves or no, because he wasn't able to see. So what he did was he introduced some fluorescent or like phosphorescent material here. Okay. So what is basically fluorescent or phosphorescent? Do you all have any idea like what it is? Heard? You heard about fluorescent materials, phosphorescent materials? It glows, something that glows, right? But yet, like this you all will learn like probably in your like further studies, okay, in depth. But just like I'll explain you all in brief, okay? Just the difference between fluorescent and phosphorescent. So fluorescent is something, what it basically does, it will absorb light. Okay. And then after some time, when it absorbs, that particular light which it has absorbed, it will emit. Okay. But fluorescent is only for a short period of time. Like, like unless and until there's a light source and it absorbs, it will emit. Okay. Only that. When you stop that source, right, it won't function. Okay. It won't be able to glow, or it won't be able to give. Glow is what? Glowing is what? It will give that source back, right? Hence, something will glow, right? It will absorb that particular energy or light, and then it will give back the same thing which it has absorbed. Okay. So that is called glowing. Okay. So fluorescent is something which will be very temporary. Like, you provide a source, it will absorb, and at that moment of time, it will glow, it will give out. Okay. But when you take the source out or take light out, that particular thing, it will not glow. But phosphorescence, on the other hand, is, it will absorb and store. It has the capacity to store. Because you all will know, like, it is like in fluorescent, it moves from ground state, it goes to higher state, and then it will come to back to ground state. Okay, this happens in fluorescence. But in phosphorescence, there is some another state which is on top. So what basically happens in phosphorescence is it will move from ground state and it will move to an intermediate state. Okay, which is higher than the excited state. Okay, so there it has the capacity to store some light, or like whatever it has absorbed, right? It can store it for a longer time. And then what happens is when the source, you have taken out that particular source, right? You provide a source, some light to this particular system, the material. When that light source is taken out, still it will have that capacity to give out light. Even though the source is removed, it will glow, or it will, like give out that particular light which it has absorbed. So you all must have seen like on the road, like the side, like they put that thing, right? I don't remember the exact name of it. Like those square shape like are there provided at the side of the road. You have seen, right? At night it will glow. So what basically that is made of phosphorescent material. Why? Because throughout that day it will absorb light, source of light from the sun. Okay, and at night continuous, like throughout night it will glow, so that you don't fall and all, like they provide that seed like that. So I am not getting like here. What about glowing pen? Huh? Glowing pen. Yeah, glowing pen also will be example of phosphorescence, no, because it can glow for a longer time. Okay, so yeah, so this was, you all don't have this in there. So you all don't have you all don't have phosphorescence and fluorescence in depth. Okay, it is just for your, yeah, that is some, yeah, that is a fluorescent color, no? Like we are speaking about some material, like, yeah. So basically, you all don't have these concepts in depth, okay? Just for your idea, like just so that you all have a brief idea about it, I give you some extra things, okay? So what this particular person did is he, used some fluorescent and phosphorescent material here, okay? So what was done is when he inserted some material here, he passed this rays when moved towards this, right? It moved towards the positively charged anode. Okay, when it moved, this would glow. Okay, so in other ways, like like this was a proof line. Okay, when this part, when the cathode rays would move, it would strike the anode. This particular, due to the fluorescent or phosphorescent material, this would glow. Okay, so hence we concluded that like since this glows, then the rays must be like moving in a straight line. It must be moving going from cathode to anode. Another thing which he observed was without the electric and magnetic field, okay, the rays they moved in a straight line. Okay, it was seen that they moved in a straight line towards the anode. But when he introduced some magnetic or electric field right here, he observed that this cathode, since it is negatively charged, right, they acted like electrons. Okay, what are electrons? Electrons are also negatively charged, right? So he observed that the cathode, when you introduce some electric and magnetic field, this particular charged particles, right, they were acting like electrons. Okay, so he basically came up with the term negatively charged particles are electrons. Okay, so in this particular experiment, it was proved that the negatively charged particles they acted like electrons. Okay, any doubts? Understood? You want me to repeat again? Understood, right? So basically in this also, like it depends, but you all just have to have a rough idea, okay? And no need to like by heart and all. Just understand and then you can write in your own words, okay? This was basically a small experiment which was performed. And the diagrams which I drew, right? Those are important, okay? Like it depends like on like from higher secondary. So they may ask you, okay? So you all can practice like at home, like draw and practice those at home. Okay. And second one is Thomson's model. Okay. So you all know something, heard, studied about it, heard about Thomson. Okay. So basically, in Thomson's model, so this is also called the watermelon model or pudding model or date pudding model, like he gave many names. Okay. So further on, like I'll explain you like why this particular name was because it looked similar to a watermelon. Okay. So what he said is what Thomson said. He said that when you like a atom, okay, it is uniformly distributed with positively charged. Okay. There's positive charge which is uniformly distributed, okay, throughout the atom. Okay. And what he said, although there is positive charge, there are also negatively charged electrons which are embedded inside this. Okay, so there is positive charge, no doubt about it, but there are also some negatively charged particles which are electrons to be more specific, okay, which are also present here, okay, in this. Then, so because of this, he gave the name as, watermelon. Why? Suppose if we cut the watermelon, right? The watermelon has seeds. So seeds resembles the electrons, okay? And that fleshy part of the watermelon, right, red, it resembles the positively charged, okay? So basically, Thomson came on to this conclusion, okay? So then what are the drawbacks of it? Still, like like though Thomson said that like there will be positive charge and the electrons are embedded, there were drawbacks. Drawbacks are something like you people also can see, like if we compare to the present model, okay, like what we consider the positive charge inside the nucleus, right, and outside it are electrons. Okay, so there will be drawback to this, right, because this is not like same as our atom, like now present day atom, right? So what are the drawbacks? He said that first one was the mass of the atom is considered to be evenly spread over that atom. Okay. So he said that basically the charge is spread, right? But in our present model, the charge is not spread. It is embedded in nucleus, right? So first one was that. Second one, he said that his model was a static model. So there was no movement, okay? Like we know, like he just said that the electrons are embedded, but he further on did not explain like whether the electrons are moving inside that like the atom or what, that he wasn't able. Like he did not give any further justifications to that. Okay. So if we consider like electrons are something which moves, right? They revolve around the nucleus. So, but he did not justify that. Like he just said that the electrons are embedded. So second drawback is his model was a static model. Okay. And the third one was he wasn't able to explain the stability of the atom. Like, like how the atom will be like stable, or whether it will remain, or like how. Like now, suppose if we consider our model, like the atom, we say that the positively charged is balanced by the negatively charged. Okay. Like for example, if you have the nucleus contains what? Positively charged protons, right? So suppose if I have three protons, okay. So how much electrons should I have? Three, okay. So if some of you all, if you all have studied the chapter, you all will know, okay, the number of protons should be equal to the number of electrons. Okay, you all will have idea. But in case if those who are studying this chapter new, right, if you all have not studied in your high secondary, then you should know that, you know, the number of protons should be equal to the number of electrons. Okay, why this? Why am I saying, or like why the protons and electrons should be equal is because, like suppose if you have three protons, protons is positively charged, right? Positively charged, three positive. Suppose if you all assume that you have three positive charges here, okay? Then surrounding it, you should also have three negative charges. Why? This should balance, like, you know, three positive and three negative will be null, right? So it should balance out each other. If it balances only, then that particular atom will be stable. It will remain intact. Or else if it is not, if the charges are not balancing, right, it will collapse. Like you won't have an atom in nature, okay? And because of this concept, right, because of the charges, like it should balance, the ions come into picture then. Further on, you always study about ions, cations, anions. Why this comes into picture is when the charge is not balanced, right? When the positive and the negative charge is not balanced, the partial positive, okay, like charge, I mean, sorry, the partial charge, the net charge, you write it like, you know, in the form of like Na plus and all. So this is basically the net charge. This is the net charge. So like after balancing, whatever charge is there, right, you write it here on top. Okay. So basically this was a brief idea. Okay. So basically because of that, these are the three drawbacks. Okay. Well, I've understood, right? So you all have to know drawbacks are very important. Like you all may get a question. Okay. So you all may write it. Huh? Rutherford, what? Yeah. So basically, drawbacks are what? Drawbacks are something failures you can consider, right? Like drawbacks are like, you know, like since there was a big competition, okay, there were many scientists like first. Like each scientist had proposed his or her own model, like, you know, they came up with their model and they were competing with each other, saying, yeah, okay, like, my theory is right, my model is right. Some other person said, no, like you're wrong. So because of the further on theories which came up, right? They proved his Thompson's model as no, like this model is not correct, okay, because they came up with their own models. So according, yeah, like Rutherford and all, like model you always study. So because of that, these were the three drawbacks to this model. Okay, so basically drawbacks are asked for exam. Uh, Rutherford, what? Maybe like, you know, like it is like when you propose a particular, okay, like suppose if you have some model, it takes like many years for it to get, you know, proposed, like for it to, you know, get published on a book and all. So there are many things. So there's a big like council sort of, and they sit with all this and all. So that time they go through, they discuss and all. So it takes many of years to suppose if you want to publish a paper also, right? Like suppose if you like in any field, say for that also it takes like 5 years, 6 years and all. So basically they came up and then they said that okay, these are the faults in your model. So hence his model wasn't like considered as the appropriate one. Okay. So Now we have seen Thomson's model. Now we will speak about Rutherford's model. Hmm? Rutherford's model, okay? So Rutherford basically he came up, he also performed a simple experiment. Okay, so what did he do was he took some gold foils. Okay, gold foils he took, many gold foils, and he passed some alpha particles. Okay, positively charged alpha particles. So he passed some positively charged alpha particles onto this gold foil. Okay. So when he passed the positively charged alpha particles, what was observed that, some of the alpha particles, they got deflected. Okay. Some passed through, but some got deflected. Okay. And some he observed, some bounced back. Okay. So here also you all have to know this, okay? Like what are the three observations which he's observed? Okay, one was when he passed the positively charged alpha particles through the gold foil, he observed that some of the alpha particles they got deflected by small angles. Okay, deflected meaning they changed their path. Like first they were moving straight, right? They changed their path and they went somewhere else only, like that. So that is called deflection. Okay. Second one, he observed that many, like most of the alpha particles, they were undeflected. Okay, meaning they moved. They were able to pass through the gold foil. Third one he observed was like very few of the alpha particles, what they did was they moved and then they bounced back. Like came like that, they moved and then they bounced back by 180 degrees. Okay. So these were the three observations. These were the three observations. What happened? Okay, which something is there. Okay, so these were the three observations which he observed. Okay, so like you all may get a questions like which are the like observations which you observe. So these 3 points you all have to know. Okay. Further on, like coming on to the observations and conclusions. Okay, so the first observation or conclusion was that most of the space in the atom is empty as most of the alpha particles pass through the gold foil undeflected. Okay, so like see why will something just pass through when there is nothing? Like suppose if I want to pass, okay, like if I want to pass through, like if I want to come from this point to that point, will I be able to pass through this? Why? Because there's an obstruction here, right? So this will oppose me, right? So I won't be able to pass. So here, okay, here, I'll be able to walk straight, right? Why will I be able to walk straight? Because nothing is there in my path. So I'll be able to walk straight. So same way he also did, like meaning he came onto this conclusion that there must be some space, like unoccupied space, which is there. Because of that, only like the particles, the alpha particles, they pass through undeflected, right? So first observation was that about space. There must be some space inside. Okay. Second thing, he said that he spoke about, the repulsion. Okay, he spoke about repulsion. So why repulsion is because now alpha particles are what he considered positively charged, right? And suppose if you say if a system has positively charged particles also, suppose if the gold foils they contain positive charge also. Okay. Now what will happen is by nature we know that positive repel, right? Negative, positive, attract. Okay, same rule he also, like followed. Since they are positively charged, alpha particles are positively charged, which he passed through, and there must be some positive charge in those gold foils. He said that because of that, they must have got deflected or repelled. Okay, so there was some repulsive force Because of that, they changed their direction and they got repelled. They weren't able to move straight. They weren't able to, like move straight and reach this point. Second observation was that. Third observation, he calculated the, size of the atom and the nucleus. Okay. So after calculating, he said that the radius of the atom, it must be 10 raised to minus 10. And of that, of the nucleus, it is 10 raised to minus 15. So what is small, 10 raised to minus 10 or 10 raised to minus 15? 10 raised to minus 15 will be small, right? So through this, he concluded that the nucleus will be something smaller than the atom. Okay. So yeah, so basically these are the three observations or conclusions. So you all may get a question from here also. Okay, understood, right? So then, after all these observations and conclusions, he came up with the nuclear model of atom. Okay, like the final, like this was basically like an experiment which he performed. Then he predicted like based on the observations and all. But now finally he came up with the nuclear model of atom. Okay, so what this model says is that the positive charge and most of the mass of the atom was densely concentrated in extremely small portions. Okay, now like it says that the positive charge, okay, basically the positive charge was something which is not present throughout. Okay, like unlike Thomson, what Thomson had said that the positive charge is uniformly spread, right? Like throughout it is spread. Okay, but he said that suppose if the positive charge is uniformly spread, then why was some alpha particles able to pass through and why they were undeflected? He made a question mark on that. Like, why that? So, because of this, he said that no, it can't be like the positive charge, it can't be spread throughout. Okay. The positive charge will be only embedded in this nucleus. Okay. And the negative charge will be surrounding the nucleus. Okay. So, he said that. Then, yeah, second point speaks about the electrons. So he basically said that, the electrons are something which are surrounding the nucleus in orbits. Okay. So, yeah, so this was about the electrons. Then he said that now suppose it for the atom to be stable, like there should be some force, right, to keep it like present in the atmosphere. There must be something, right, to keep. Suppose if it is not balanced, if it is not stable, then it will just collapse and fall, right? So he said that there must be some force. Okay. So he spoke about the positive and the negative charge, the force of attraction, okay? The electrostatic force, to be more specific. So he spoke about the electrostatic force, which keeps the atom intact. Okay, so the electrostatic force, he basically says that the electrostatic force is because of the protons and electrons. Okay, understood? First, he said that the positive charge must be embedded in the nucleus. Okay. Second thing, he spoke about the electrons which surround the nucleus in orbits. Okay. And third thing, he spoke about the electrostatic force which must be keeping the atom stable. Okay, understood? Any doubts? Okay. Since he spoke about all these things, right? Yet there was some drawbacks, okay, for his model as well. So let us discuss what are the drawbacks. So the first drawback of feeling cold. So I'll put off the AC. AC is no, she did some face in mirror. AC is fine. Okay. You're okay, right? With the pen. You'll want to put it off. I'll put it off. Okay. So now, yeah. So now let's discuss the drawbacks. Okay, so there was this another scientist called Maxwell. Okay, so his theory always study like probably in your next class. Okay, so he studied some more like further on. Okay, on the structure of the atom. So according to Maxwell, what Maxwell said was he said that you said right, like the electrons are present outside the nucleus. So according to Maxwell, he said that suppose the electrons are present and they move, they should give out some radiations, right? Like if something moves, something just can't move like that, right? It should give out something, some energy or some sort of source it should give out. So Maxwell said that, okay? And Maxwell also said that suppose if electrons moves, okay, and it gives out some source of radiation, say, if that is so, then it will keep on, like it will just give, and once it is done giving, what will happen is it will shrink because it has nothing more to give. Okay, so he spoke about this. So basically, Maxwell spoke about like some radiation or some energy which the electron should give out when it moves around in orbits. Okay, but Rutherford wasn't able to explain this. He had no answer to this because he just said that the electrons are present in orbits, right? What they do, or they move, or like what they do, they move in a circular motion. Of that, he had no answer to give. Okay, so because of that, this was the first drawback. Okay, he wasn't able to give an answer. He had no answer for this. So because of that, this was the first drawback. Another drawback was the distribution of electrons around the nucleus. Okay, like how are the electrons distributed in like around the nucleus? Like yeah, like he just said that they are distributed in orbits, but he wasn't able to explain that, the orbit will contain how many electrons that came up further on. Okay, saying that there are K, L, M, and so shells, right? So K will contain just 2 electrons, L will contain 8 electrons that came up further on. Okay, but so far when he proposed his model, he had no answer to this, whether like how many they are just like occupied, or they are just filled enough, like, or like how are they arranged inside in that orbit. He had no answer to that. Okay, so second drawback is speaks about this. Okay, understood? Do you have any doubts? So basically drawbacks are important, like mostly, like then the postulates, then the experiment, right? The drawbacks are more important. Okay, so Thomson's drawbacks you'll have to know. I think there are three, right? And this two. Okay. Just you all can write in your own words, like just you have to understand first the model, and like why wasn't able to explain like the present model. Just compare it to the present. Okay. So then you will get your drawbacks right in that way. Okay. So now think I okay. Now we will go on to solving. First I will explain, and then you all can like we will solve some numericals. Okay. Atomic number. So what is an atomic number? What is the atomic number? Yeah, right. Okay. So basically, atomic number is nothing but the number of protons present in the nucleus. Okay. So basically, atomic number is nothing but the number of protons which are present in the nucleus. Atomic number can also be the number of electrons present in, the atom, provided it is of a neutral atom. Okay. So, yeah, so atomic number, and atomic number is represented by capital Z. Okay. So this you all have to know. First, you all have to know like what is the atomic number. Atomic number is nothing but number of protons which are present in the nucleus. Secondly, it can also be the number of electrons provided they are of a neutral atom. Okay. So I think I just mentioned no number of electrons. First, I mentioned that atomic number Z is equal to number of protons, and after that, I mentioned number of electrons. Just write add there, no, after number of electrons in a neutral atom. Okay. Here, you did not get the notes. So then you should have told me no start. Think the question right now. You all wrote right. I want you to write number of electrons in a neutral atom. Okay, because you all will, when we solve problems, right, you all will come to know like why specifically I told you all to write of a neutral atom. Okay, so basic atomic number is nothing but number of protons which are present in a nucleus. Besides that, it can also be number of electrons, present in an atom, provided the atom is a neutral atom. Okay, and it is represented by capital Z. And another term, do you all know when you have protons and neutrons together, it is called huh? Proton and nucleons. Okay, when you have protons and neutrons together, it is called nucleons. Okay, so this was about the atomic number. Now coming on to mass number. So mass number is represented by capital A. Okay, mass number is nothing but the number of protons plus neutrons. Okay, so both when you have your protons and your neutrons, this will comprise of your, or that will give your mass number. Okay, so this much you'll have to remember. Now, another thing is when I want to represent any element. Okay, for example, X. Okay, X is my element. So now, like, how will I represent it? I will represent it by here it will be A, on top it will be always mass number. A is what? Your mass number, right? So mass number will be on top and your Z will be down, okay, which will be your atomic number. You can also some textbooks or some books also show as A here and Z here, okay? But this concept, okay, that your mass number remaining on top, that is fixed. Maybe left or right. Mass number is always on top, atomic number is always down. Okay. So yeah, if you all are done with this, there are some numericals. The first one, calculate the number of protons, neutrons, and electrons in bromine. Okay, so how will we solve this? So what are we given? We are given bromine and 80 and here 35, right? So what is 80? Yeah, you can go. Right. You know that the is. Okay. So now, yeah. So coming on to question one. So I have 80 and 35. So what is 80? Mass number, right? So right, mass number is equal to 80. And what is 35? Atomic number. So atomic number is 35. So what did I say? Like what is atomic number? Atomic number is nothing but number of protons or number of electrons provided it is a neutral atom, right? For electrons, this particular element should be a neutral, okay? Neutral element. So is bromine, is there any charge on bromine? No charge, right? So it is basically neutral, okay? So since it is neutral, we will say that number of protons is equal to number of electrons, okay? That will be equal to 35, okay? Now we have found out number of protons and electrons. What is remaining? Neutrons, right? So now we have to find number of neutrons. We know that mass number is equal to your protons plus neutrons. The mass number is given 80 and protons we have calculated previously, okay, from the atomic number. So atomic number 35 plus n. So neutrons will be 80 minus 35, which will be 45, right? So neutrons are, huh? Any doubts? Neutrons will be 45. Understood? Any doubts? Last class, I feel you absent me. So you had taken last plan to the recorded lecture. No, yeah, I completed the first chapter is completed. I started with the second chapter. Started the second chapter like I just given an intro. So actually now I started the actual with the second chapter. But I think first chapter you missed out on some problems. Some yeah, like I had saw some problem where like three concepts and all were involved. So that you have missed out and that empirical and molecular formula. That is very important. Okay, like it comes for sure. So that you have missed. So Resmi ma'am, you are maths, right? So just tell ma'am to send the recorded lecture, okay? So then you can watch and tell her which lecture. I feel it was sixth one. Okay. Just say that I missed the sixth lecture and I wanted like but you all were taught empirical and molecular formula is not taught. Because for the test and all it will be difficult for you. Because of that. So understood this. Okay. Yeah, try solving the next one. Solve the next, try solving the next one. Huh? You did not get the question then. Yeah. No, at least some parts you'll can find number of protons and protons and neutrons you can find, no? Only electrons will be a problem since it is a neutral atom. But you all found out number of protons. What you all got for number of protons? What? Ah, okay. Okay. So basically, the question says we are provided. Okay, so in this case, we are provided the number of electrons, protons, and neutrons. Okay, and we are told to find the element. Okay, my bad. I just mistook the previous one as this question. Yeah. So how will we do? So protons we know how much are protons? 16, right? Electrons are 18. Neutrons are 16. Okay. So now to find, okay, now so now I have to represent it says the question says here I want to find, we have to find the element, okay, and we have to represent it in this form. Okay. This is right? A is your atomic mass. Oh, sorry, mass number. And Z is your atomic number. Okay. So now I want, like, I'm given the number of protons, electrons, neutrons. I have to represent whatever is given in this form. So to represent this particular information in this form, what will I have to find first? Mass number and atomic number, right? So how will I find atomic number? Number of protons, okay? So now, okay, like X. So number of protons will be basically Z, right? So what are the number of protons? 16. So now what is left? Mass. So mass of electron will be, the mass number will be what? Protons plus electrons. So it will be 32. Okay. But now you must have got a hint. This is not a neutral atom. Why it is not a neutral atom? Electrons are extra. By rule, electrons should be 16. Okay. So, but the electrons are extra. Okay. So the extra part, right, we comprise that for the charge. Okay. Like the net charge. I spoken about the net charge, right, previously. So whatever net charge is left, right, like that will be present somewhere here. So that will tell you whether it is a whether it is a cation or anion, basically. Okay. So cations are nothing but cations are positive charge and anions are negative charge particles. Okay. So now, like suppose if I do 18 minus 16, how much remains here? 2. Okay. So now whether it will be negative or positive, like how will I find that? Does anyone know? Like, how will I find? Like whether to write positive 2 here or negative 2 here. Yeah. So what it will be? Huh? Negative. Okay. So basically it will be 2 minus, or you can write like some people prefer to write minus 2, but minus 2 is like not that much appropriate. So you write 2 minus. Okay. All understood why 2 minus? Okay. So simple thing you all can understand like this. Okay. Suppose if you have now 16 protons are present, right? 16 protons meaning 16 positive charge. Okay. So how much negative charge will I require? I have 16. I have 16 positive charge, like 16 protons, which are positive charge particles. So to balance this out, how many electrons will I require? No, balance meaning like to get it like null. It will be null, like to balance it out. 16. Okay. So this will be minus 16, right? So minus 16. So plus 16 minus 16 will balance out each other. It will become 0. Okay. But we also know that when we speak about electrons, electrons are negatively charged particles, right? So since electrons are negatively charged particles, this minus 2 of electrons, they are still remaining. Okay. So minus 2 is still remaining. So because of this minus 2, you write 2 minus. You can apply that also. When you gain something, it is always negative. Like in terms of, I don't know whether in your lower classes you'll have studied that, but when you lose something, it is positive. When you gain something, it is negative. Okay, so you can apply this concept also. But in case if you are very confusing, if you find that concept confusing, then you can say that since it is electrons, and in this case, we are electrons in excess, because of that, it will be minus. Because what will be the charge of all electron? It will be always minus, right? So because of that, this will be minus 2. Like the net charge will be minus 2. Okay. So you all can, like apply this concept also and then write. Okay, both the concepts are right. Okay. Yeah, solve the third one. Here you all don't have to find x. Okay, x is just an element. You all just have to find the mass number and atomic number. Hello, boy. What do you want? In your mom message. You are Lisa. Lisa. I think her like her mom must be like she has explained that she's not there or something. You have informed them about this. For what time? I'm sorry. You did for what time you're leaving? Like, done, solves. So number of protons will be 89. All got 89. Hmm? Then neutrons will be 142. All I've got. You got? No, you didn't. You got? You are just lost in your own world. Like. Then number of electrons will be 89. All got right. You already solved. Hmm? Understood? Okay. So now solve the fourth one. Fourth one is a bit like difficult. You'll have to apply. A bit of application is required. It is like NEET. NEET question. Huh? Yeah, but it is like one question from NEET. Like I've just included. What this question says is nitrogen atom has nitrogen atom has an atomic number of 7. Okay, so atomic number is 7 and oxygen it is 8. Okay, so basically what information do you get? Number of protons, right? Then it says that the total number of electrons in a nitrate ion will be. So what is nitrate ion? So there are basically three concepts. Okay, one is nitrate, the other one is nitrite, and the other one is nitride. D. Okay. So now what is the difference between all these is when you say nitrate, okay, when you have this A, it will be NO3. Okay. When you have A nitrate, it is 3 and the net charge will be minus, just 1, okay, like -1. Now nitrite will be what? Nitrite will be NO2. Charge will be minus only, like -1, okay? And nitride will be, sorry, N3 minus, okay? So you all can remember is normally like when we go alphabetical order, right? A comes first, I comes after, right? Right? So when you say A, it should be, okay, suppose if we go alphabetical order, A comes, then we get I, okay. But if we consider the numbers, 2 comes first and then 3, okay. Here what you have to do is, it is like the opposite. A will go with 3, NO3, okay. Net charge will be the same, minus, minus. But A will go with 3 and I will go with 2. So just remember, like since A is first and 2 is also first, but A will pair with 3, opposite. It will be opposite. Okay. So you all can remember this, and this is like exceptional. Like D, when you have nitrite, D, it is N3 minus. Okay. But these three terms, like suppose if further on for like organic spotting also, like you all will like require this. Okay. So it will be beneficial like for you all. So just a note, like, so you all can write a note on top and all, and just remember for you people, like for NEET, JEE and all, suppose if you'll answer, then this parts and all, like here and there, right? Like this will be very beneficial for you people. Okay. And when I say, right, like this is NEET and all, like if in case if you all are aiming like for NEET and all, what you all can do is don't just write there, but like you all have the space on top, right? So what you all can do is write a note and then write there. So then like when you all actually answer and all, when you all prepare, that time you all can quickly like brush through and all. But are you all preparing? Like you all started preparing NEET, JEE? Not you all have not started. But here, like sincerely, like who is aiming like for NEET and all? JEE, NEET, no one. You what? You will not be doing it in India. Okay, okay. No one is answering. No one will answer NEET. Okay. So what do you people like? First starting when I asked you, like all were like NEET, G. Like I heard those answers. So just one. Only Sanvi will answer. So you started preparing. So what you all like what you do, like don't stay like, like last minute. Like most of the students, like what they think, even I, in fact, like I had studied like when I was in 12, in fact. But the correct thing, to study is 11 because now CV start fresh, right, with all the chapters. So NEET will comprise of all 11 plus 12, Suppose if you just say that, okay, after when I be in 12, I will target that is, you will just cover your 12th standard, okay? This basics will remain, right? So it is like now, like since though you go for tuitions and all, you can purchase those books online, you get na NEET, and those books are chapter wise. Like first chapter was some basic concepts of chemistry, right? That book will contain all 10 chapters. So what you can do is like when we finish one chapter, like that chapter is over, that chapter is started, right? You can solve at least like 5 or 10 new MCQs per day. So like that much you will, and suppose if you just solve 5 or 10 say per day, we have 365 days, or like say if you just keep 300 days, okay. So then just see how many MCQs you will solve, right? So because of that, start. And this part is fresh, right? So you can start with your JE also, and you can focus on your 12 also. 12, basically, JE is nothing new, okay? It is some extra things besides your Goa board, okay? So what you can do is these things you study only, right? For 12, you study only these things. So besides that, you can make like some extra things, make a separate book for you, like all the formulas and all, right? And then you can like do that also and compare. And for Goa board, like when you have your exam, just stick to that. Okay. And okay. I thought that you'll be answering me also. I no, I did not like actually I had plans like of going for MBBS and all starting. So then it was like it was just like okay, I wanted to be a doctor, but then I had interest towards chemistry. Like again, when I had my NEET exam, right, this lockdown came into picture. So it was like 2020. Okay, so I just answered my board exams, right, 12th board, and then I had the second language or second language I feel I had, and then the next day it was lockdown. So I was very like like happy. I could finish that paper, and then the lockdown came into picture because some students they had to wait for 2 months. So 2 months they had to study the same thing and all. So because of that, and NEET was rescheduled like after 3 months or something. So I had to prepare that. First, I was very happy, like I will get to prepare and all longer time and all. But then when I started preparing, I noticed that my chemistry part was done fully. Like I was done with all the chapters, but bio and physics was still like remaining. So during that time, I felt that like, no, I don't have that much interest towards bio, and NEET is all bio, right? So I did not want it to go. Then I dropped that. But that was a very difficult phase for me also because um my parents like they thought that I would pursue MBBS and all. And I had interest towards chemistry, right? And that's just bachelor's. So then what they said was like you are firm and all, like why not like you go for MBBS now and all. So those all those things and all, and it was a very stressful phase. Like I did not want to do like whether I have to drop this or like go there and all. So that time it was like I was sick for some time and all like that. It was a very terrible phase. But then but then I was firm. I had liking towards chemistry. That thing I was firm. So I told them, like I don't want to do MBBS because suppose if I go, suppose if I pursue also. And if I do my second year and all, and what if I do like if I don't find it interesting and all, then I'll drop, right? So didn't want to take that risk, go there and then discover and then come back, So I was like, no, I'll do BSc only. So then, yeah, I answered. Then for GWAT and all, we have this GWAT exam for masters. So GWAT also was pretty cool. Like, yeah, I started like starting of my BSc only. Because I was firm, like I wanted to go for masters. So when I was in bachelor's, first year only, though first 2 years were lockdown, right? So I started preparing for GWAT and all. And during that phase, like no one knew like you had to prepare and all for GWAT. So because of that, I got like a ninth rank for uh, chemistry, GWAT. And some students like what they did was they just studied after BSc, meaning they BSc got over, then we had to apply for masters, right? So just 1 2 months like they answered and they give like just like thukka, like just luck and all. But doesn't happen if you are really firm with a particular thing, Hence, I was telling you because even I, for the first, like for, when I was in 11th, I did this mistake. But when I was for bachelor's, when I was studying for bachelor's, I was very firm. I wanted to pursue master's. So I started preparing from my first year itself. So this 3 years ka things were very firm and very, I was very firm with my basics. So same thing I was telling her also. Like now, like, like you are starting your basics, right? So if you are very strong with that, then you'll be able to answer any question of NEET and JEE. Because for all the applicative questions now, your base has to be very strong. Okay? So yeah, done. It's just like a just quick break, like from specific questions. So yeah, done. Now how we all will solve? Hmm? So now what we know is now which one we have to take. So it is question 4. Okay. So it is nitrate, right? So basically we have to find the total number of electrons which are present in this species. Okay. So sorry, what information are we given? We are given the atomic number, that is 7, right? This is for nitrogen. We are also given the atomic number 8, that is for oxygen. So how will we find? Apply. Like I want you all to think and still have time. How will we proceed? Because it is like it is no point ki I giving you all. If you all think a bit, then you all may come up with something like so your mind has to, like work. It is very simple. Huh? Multiply it by 3. Okay. So he gave a small hint to that. So now what we have to multiply that you all have to tell me. Hmm? Tell. No, you missed by. And I know like you're going in the right track, but you just missed by one. No. 32. Yes, right. How you got 32? 31 million negative charge. Yes. All got. Okay. So now atomic number is what basically? Atomic number will be the number of protons or number of electrons. Okay. But I said be careful when it is not a neutral atom. Okay. So what I will do is I will take that charge also into consideration. So what I will write is I will take the number of electrons of nitrogen. How much it will be? 7 plus 3 into how many of oxygen? 8. Okay. Is equal to, this is negative, right? So this will be the total number of these electrons will be equal to the net charge. Okay. So now 7 plus 8 3 is 24, right? So this will be 31, right? Okay. So now it is, now what I will do is I will get all the terms on one side and I will equate it to 0. Okay. When I get this negative charge here, it will be 31 plus 2. 1, sorry. So it will be 32. Yeah, sorry. So it will be 32. Okay. How many of you all could solve this? Who weren't able to solve? Huh? Okay, 31. Okay, right. But at least like you all were able to, like apply, right? Like take this as the number of electrons. So that is very important. Okay. So because of that, I told you, please solve those MCQs and also your brain starts becoming very active at solving. Okay. So yeah. And the next one. So let us solve question 5. So what does question 5 say? Question 5 is, it says that is Na plus ion isoelectronic with Mg plus 2. So it says that Na plus, if it is isoelectronic with Mg2 plus. Okay, so what is isoelectronic concept? Okay, isoelectronic is nothing but the species which have the same number of electrons, but the charges on it, they vary. Okay. So in simpler words, I have to check whether the number of electrons in Na and Mg will be the same. Okay, so if the number of electrons in Na and Mg, if they are same, no, we call it isoelectronic species. The charges can vary, like this can be negative also. Irrespective of the charges, the number of electrons should be the same. Okay, so if I say that the number of electrons, okay, like Na will be 11 and Mg will be 12. Okay, suppose if the atomic number is given. So now I want you all to check and tell me. How you all will do? You'll understood the question. This side you'll understood the question. Last bench understood. I said that these two, I have taken two species. One is Na plus and Mg2 plus. Okay. Now I have to check whether this will be isoelectronic with this species. Whether I have to check whether this if this both are isoelectronic species. Okay. So for that, what I said, isoelectronic species is something which have the same number of electrons irrespective of the charges. Okay. This can have some other charge, this can have some other charge. Okay. But the number of electrons in both the species will be the same. To be isoelectronic in nature. Okay. So the number of electrons in Na plus will be how much? Na plus. So basically, normal Na will contain this atomic number, right? It is for normal element, okay, or neutral. So basically, Na will be 11 and your Mg will be 12. Okay. So now I have to find the number of electrons in this species. Of this species, you know, when there is no charge, sodium will be 11, Mg will be 12. Okay. So now how will I calculate? Class is what? Class is when you take something from it, right? That species will acquire a positive charge. And negative charge is when something, like when you give something to some species, right? It will be negative, okay? In further on also, you all will learn another concept about, okay, just to be more specific, there is something called as electrophile and nucleophile. You all heard about it. Just to add, okay, like maybe these terms may just help you out and further on. We have something called as nucleophile and something called as electrophile. Okay. So when we have a particular reaction, right? Or like say in organic also, and in this also, like when we have the cation and anion concept also, you know, we apply the electrophile and nucleophile concept. Okay. In what is a nucleophile? Nucleophile is a rich, okay? It is always electron rich species. Okay. Electrophile is electron rich species. Okay. So electrophile will always acquire a negative charge. Okay. When any element has a negative charge, be it -2, -3, you say that that particular species is a nucleophile, as in it is rich in electrons. Okay. And electrophile is electron deficient. Okay. It will be electron poor in electron, in other words. Okay. Poor in electron. Okay. It will be very poor, or in other words, it won't have that much. Like suppose if I consider, okay, a rich and a poor, like a rich person and a beggar concept, okay. Nucleophile will be the rich person, very rich. It will have a lot of money, you can say, okay. And the electrophile will be like a beggar. He won't have anything. So it will be always poor. Okay. So nucleophile is something which will acquire a positive charge. Okay. These two terms I've introduced just for you all to know. Okay. So yeah, so suppose if we apply that concept also, Na plus meaning what? Less in electron, right? So positive charge meaning one electron less. Okay. Then Mg2 plus meaning two electrons less. Okay. So if we go by that, the atomic number of sodium was 11. Okay. So if I write Na plus meaning you have to do minus 1 from there. So how many electrons will sodium have? 10. Mg2 plus. So 2 less. Okay. So it will be also 10. So both are isoelectronic to each other. Yes. Okay. So you all understood, right? So on my notes, I have not mentioned about isoelectronic concept, but you all can just make a note key. The number of electrons should be same. In other words, you can write that isoelectronic species are species which have the same number of electrons, irrespective of the charges. Okay. So with this, we will stop for today.